Hello everyone, welcome to the HSPF training by DSI. This is video HSPF630 reviewing the water quality parameters for RCHRES operations. So let's continue where we left last time and we'll directly go to the RCHRES parameters and okay, so for RCHRES, if you see the activity, hydraulics, advection, heat, sediment, general quality, fecal coliform is general quality, oxygen, nutrients, plank means the biochemical transformation, eutrophication, chlorophyll A, those kind of things. Then we'll scroll down, heat. So these are the parameters that relate how the heat from the river bed is transferred to the water. So all of these parameters relate that. This is how much area of the reach is covered by the shade. So if is not covered by shade, so 0.95 means 95% of the area is open to the solar radiation. So that it can absorb heat. Again, these parameters are for transferring heat from water to the sediment bed. Sediment we have looked at earlier. General quality, number of general quality constituent 1, only water, only fecal coliform here. And then what's the source of temperature and pH time series if needed. Initial concentration of the constituent is 50. The unit that we want to use is organism per liter, and this is the conversion that transfers the number of organisms earlier on the land surface to here, the organism per liter. So this is very important. If you use a different quantity ID earlier, you may want to adjust this conversion here. These are the flags on what kind of operations will happen with the general quality constituents. Gen means general first order decay. S- means if it's associated with sediment or not. This is the coefficient for first order decay, temperature correction coefficient. Then that's done for the general quality constituents. Benthic flag, if there's benthic release happening. Oxygen, dissolved oxygen, they said different ways in which you can simulate dissolved oxygen. We'll not go through all of these parameters. I would suggest you to look at on this HSPF training page this resource, MPCA technical note on water quality parameterization, and this technical note actually has all these parameters, what are the limits of these parameters and what is the effect of each parameter. So this is a highly recommended source, and this should be useful in getting the proper values of a lot of these parameters and how to even calibrate it. In this case, all the reaches 1 through 54 have the same parameter, but in general, if you have reaches, lakes, upstream reaches, small shallow reaches, you will have different parameterization of those. Initial values, nutrient flags, what will be simulated, ammonia, nitrite will not be simulated, phosphorus will be simulated, and we'll have to look at these. If I look at nut flags quickly, so ammonia, so volatilization, denitrification, and adsorption is simulated or not. So those are the parameters here. These are the conversion from biomass to oxygen, conversion from biomass for phosphorus. These are the amount of nutrients released from the bed, nitrogen, phosphorus in aerobic and anaerobic condition. Again, these are different coefficients, initial values, plankton, phytoplankton, zooplankton, whether that will be simulated or not, ventricality is being simulated. And then again, these are parameters: maximum growth rate, that's the extinction coefficient for light, optimum temperatures, and these are the multiple parameters that are used for simulating phytoplankton. Again, this video is too short to go through all of these parameterization details. I would highly recommend you to look at this document, and then feel free to ask questions or discuss these things in this YouTube channel itself, or we have a basins group on LinkedIn, or there's a basins listserv also. So there are multiple sources for you to discuss and find out. Finally, I want you to look at Masslink block. If you remember, on the land surface, the water is simulated in acre inches, but inflow, what the water likes it in the reaches, it likes it in acre feet. So this 1/12 is used for converting that. PO call 1, the first quality constituent, that was fecal coliform, that is just going to ID call, and it already has its conversion through its G call place, G call flag earlier. Second quality constituent is nitrate, and NUF1-2 is nitrate. So if you want to click, NUF1 has multiple subscript 2, 1, 4. So let's look at what that is. So NUF1 is nitrate, 2 is total ammonia, 3 is nitrite, 4 is phosphate. So second quality constituent is ammonia, that is going to NUF1-2. Third is nitrate. Fourth is phosphate, going to phosphorus. Fifth is BOD organics. 40% of that goes into OXIF2. OXIF is dissolved as DO, and OXIF has two subscripts, 1 and 2. 1 is for dissolved oxygen, so dissolved oxygen that is simulated on the land is going to OXIF1, and 40% of organics that are simulated on the land goes as BOD in the RCHRES. 0.048 is multiplied to the organics on the land to get pKIF3. pKIF3 is organic nitrogen, I think. pKIF3 is organic nitrogen, ORN. pKIF4 is organic phosphorus, and 5 is organic carbon. So 0.3 is multiplied to get organic carbon. And you already know that these are the way the solids that are simulated on the surface, they are fractionated before they become sand, silt, clay. This is all the dissolved oxygen simulated on the surface is going as DO, and all the heat that is simulated on the surface goes into I heat in the RCHRES. So all the volume and mass of all of these constituents, the total volume of that goes into the RCHRES through this Masslink table. In some cases you may have to be adjusting some of these values, or you may adjust these values if you have some kind of BMP or some kind of control on the land surface. So that's it for the REACH water quality parameters, and this is very quick general overview. To get more details, I would recommend you to look at some more literature and the literature that I recommended. Thank you for your time.